Hi everyone, I hope you're all okay and you've been enjoying this week's learning. Today we're going to start our next powered maths session and it's our final lesson on multiplication today. So we're going to finish off by solving some word problems linked to multiplication. Now some of these questions will explore lots of the different strategies that you've been learning over the last few lessons. So let's take a look. Okay, so we're solving word problems involving multiplication. So let's have a look at the Discover section. And we've got another picture here today of a little boy and it looks as though he's playing with a train track and he's got a train going all the way around. And he said the train takes 2 minutes to go all the way around the track. So all the way around, 2 minutes. A couple of questions that I'd like you to think about. Question number 1A, how long does the train take to go around the track twice? Now don't forget the little cat here says twice means 2 times. So if the train needed to go around the track 2 times, how many minutes would it take? Question 1B, Charlie makes the track bigger. The train now takes 5 minutes to go around the track. How long does it take to go around twice? 5 minutes and then 5 minutes again. Okay, so pause the video and then we'll come back together. Okay, so let's have a look at the share section together. So question 1A, how long does the train take to go around the track twice? So we know that the train takes 2 minutes to go around the track once. So it would be 2 minutes, add 2 minutes. And here to help us, we've got 3 different representations. So this one here, somebody's used 2 cubes. So 1 cube for each minute, add 2 cubes, 1 cube for each minute. So how many cubes altogether? There are 1, 2, 3, 4. This person here has drawn it as a number sentence. 2 minutes, add 2 minutes is equal to 4. And then finally here, somebody has recognised that they could jump in jumps of 2 using their 2 times table. So they've jumped 2, 4. So the answer is 4 minutes. This little girl in the speech bubble said, this reminds me of the doubles lesson from last time. So we know that double 2 is equal to 4. Let's have a look at question 1B. So Charlie has now made the track bigger and it's told us that the train now takes 5 minutes to go around once. So how long does it take to go around twice? Remember, twice means 2 times. So 5, add 5. And again, the 3 different ways. So here we've got a picture of some cubes. Let's check. 1, 2, 3, 4, 5. So 1 cube for each minute. So 5 minutes, add 1, 2, 3, 4, 5. 5 minutes is equal to 10. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And below, somebody's done it as a number sentence. 5 minutes, add 5 minutes is equal to 10 minutes altogether. So 5 minutes to go around once and 5 minutes again to go around twice. And we know that double 5 is 10. And then here, somebody's used a number line and they're counting in jumps of 5. So they've jumped 5, 10. So each jump is the time the train's gone around the track. The train takes 10 minutes to go around the bigger track twice. Well done. Okay, so let's have a look at the think together. Question number 1. The car park is full. There are 3 rows of 5 cars. So there are 3 rows and there are 5 cars in each row. How many cars are there in the car park? And the cat says, draw the cars to help you. Can you organise them in an array? We know that there are 3 rows of 5. What is a row? Can you remember? Does it go down or does it go across? Right, it goes across. A row goes across and a column goes down, so it's a row. So I'm going to draw the first row of cars. Now to make it easier, I'm going to draw it as a counter. So for each car, I'm going to draw a counter. So the first row has 5. Count with me. 1, 2, 3, 4, and 5. That's row number 1. Let's draw row number 2. 5 cars in this one. 1, 2, 3, 4, and 5. And let's draw row number 3. 1, 2, 3, 4, and 5. Can you see? We've drawn 3 rows, 1, 2, 3, of 5 cars in each row. We need to find out how many cars there are in the whole car park. So to help us do this, I'm going to draw a big circle around each group. So that was 1 group, that's 2 groups, and that's 3 groups. Is there a times table that we can use to help us? Yes, we can use our 5 times table. Are we ready? 5, 10, 15. There are 15 cars in the car park. So that's the same as writing 5, add 5, add 5. And we know it's equal to 15. Let's look at question number 2. An ice cube tray has 2 rows of 8 holes. So this is 1 row that goes across. I'll put number 1 next to it. And this is row number 2 that goes across. And there should be 8 holes in each row. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. 8 holes in that row, and 1, 2, 3, 4, 5, 6, 7, 8. 8 holes in that row. How many ice cubes are there in a full tray? So that means if all of those holes were filled up, how many ice cubes would there be? Let's have a think. Is there a way that we could group these ice cube holes so that we can count in a multiple that we know of? Brilliant, so we can count in multiples of 2. So I'm going to draw a little circle around each group. That's a group, 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 and here, and here, and here. So when I draw my circles around each group, it helps me to see how many there are. Okay, so we're going to count in our 2 times table. Are you ready? 2, 4, 6, 8, 10, 12, 14, and 16. How many cubes can be in a full tray? 16. Let's just check one more time. 2, 4, 6, 8, 10, 12, 14, 16. 16 ice cubes in a full tray. Let's have a look at question number 3. Who has more counters? What does that mean, more? You're right, it means who has the bigger number of counters. So we've got a little girl here called Izzy, and she's got the yellow counters. We've got a little boy called Ben, and he's got the red counters. Now to help us, we're going to draw a circle around each group. So I'm going to draw one group, 2 groups, 3 groups, 4 groups, and 5 groups. How many counters are there in each group, in each row? You're right, there are 5. 1, 2, 3, 4, 5. There's 5 in that row, 5 in that row, 5 in that row, 5 in that row, and 5 in that row. So what times table can we use to help us here? Our 5 times table. Are you ready? 5, 10, 15, 20, 25. So Izzy has, she has 25 yellow counters. So this is the same as saying 5, add 5, add 5, add 5, add 5. So 5 add 5, add 5, add 5, add 5 is equal to 25. Brilliant. Now let's check how many red counters Ben has. So let's first of all draw a big circle around each group, around each row. Brilliant. Let's find out how many red counters there are in each row. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 in this row. And how many in this one? 10. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, add 10. Is there a times table that we can use to help us? There is, our tens. We can jump in jumps of 10. Are you ready? 10, 20. So Ben has 20 red counters. So who has more? Was it Izzy with 25 or is it Ben with 20? Which is bigger? 25. So who's got 25? Izzy. So Izzy has more counters. I'm going to write her name on the line. And we've just got 2 little speech bubbles down here. So the little girl said, I counted in 5s and I counted in 10s. So she did exactly the same as us. This little boy said, I wonder if I could use doubles. Which of these shows a double? Is it 5 add 5 add 5 add 5 add 5? Or is it 10 add 10? Yeah, 10 add 10, because that's 10 twice, 2 times. Well done. And that's the end of our Power Maths lesson today. You've been working really incredibly hard, so well done. And that's also the end of our multiplication block as well. So you will notice that in your textbook, you've got a few pages that you can explore, linked to the problem solving that we've just been looking at. You've also got some pages which are the end of topic, end of unit assessment. So I'd also like you to have a go at answering the questions on those pages too. Hope you have a brilliant rest of the day. Get your maths hats on ready because you're going to have a go at the pages in your book. Take care and I'll see you soon. Bye.